Good afternoon, everyone. Welcome to iQuanta. Now, as you are aware and you are already attending these sessions, iQuanta is providing you with a good revision and a good preparation for NMAT and SNAP 6 days a week, not 1 day, not 2 days, 6 days a week at 3 p.m. every day. And we already had 2 sessions on quantitative aptitude, and those sessions were on numbers, and I'm sure lots of you got a good revision in that, right? And today we are going to continue our sessions, and the topic is going to be permutation and combination. So I hope all of you got a good revision on this topic, because some questions are really good and will challenge you. And if you have any question, any doubt, then don't hesitate. Whenever I am discussing the solution, you can always ask your doubts, all right? So Khushi is here, Rubal is here, Paris is here, Krishna is here. Hello guys, girls, good afternoon. So let's move to our first question, right? This is the first question. How many words beginning with the vowels can be found with the letters of the word equation? So be careful when you are solving these questions. A little mistake and you might get the wrong option. Krishna already got an answer. Anyone else? Option A, Paris. Okay. So this question says how many words beginning with vowels can be formed with the letters of the word equation. So in equation, how many vowels are there? So if we talk about the vowels, we have E, we have U, we have A, we have I, we have O. And how many consonants are there? So we have Q, we have T, we have N. We have 5 vowels and 3 consonants, a total 8 letters in this word. This is I. So 1, 2, 3, 4, 5, 6, 7, 8, right? 8 letter words we need to create. The first place can be filled with any of these 5 vowels, right? Beginning with vowel. So you can either put E or I or A or O or U, all the vowels, right? This can be filled with 5 ways. Then rest of the 7 letters can be filled in 7 factorial ways, right? So this will be equal to 5 into 5040, which is equal to 25,200. So all of you who got the answer as option A are correct. Krishna, Paris, Nivedita, Rubal, Ashutosh, Bhavna, all of you guys are correct. Very good. If any one of you has any doubts, then you can ask here that how are we getting these values here. Directly 7 factorial. If you have any confusion, then ask. take this session just as any paid classes, okay? Hello Priyanshu. All right, now considering no doubts are there, let's move on to our second question. Okay, we are already getting answers as option A. Let's check it. The number of vowels that can be formed, number of words that can be formed out of the letters of the word committee. Now in committee, what do we have? We have 2 times M, we have 2 times T, we have 2 times E, right? Now if there are n terms and you need to arrange them, if A of them are similar, then total number of arrangement will be n upon A factorial. If another B group similar, then B factorial into C factorial and so on. So number of terms, total number of letters are here 1, 2, 3, 4, 5, 6, 7, 8, 9. So total number of ways these 9 words can be arranged in 9 factorial ways, but we have 2m. So 2 of the arrangement will be similar because of these 2m. Then again 2 e's and 2 t's. This will be equal to 9 factorial upon 2 factorial to the power 3, which is option A. Okay. So once again, Paris got this correct. Priyanshu, Noir, Siddhant, Khushi, Ashutosh, Srija, Nivedita, Krishna, Rubal, all of these got the same answer, which is option A, and that is also correct. Chalo, badhiya. Okay, let's try this question now. What's the answer? Option A. How many different letters arrangements can be made from the letter of the word. How many different arrangements it should be? Yeah, that is okay. Extra, in such a way that vowels are always together. So whenever you get question like this, extra, right? So there are 5 letters, but we need to take E and A together, right? We need to take E and A together. So make them as one entity, okay? Make them as one entity, then XTR. Now these 4 entities can be arranged in 4 factorial ways, and then EA can be arranged in themselves in 2 factorial ways. This will be equal to 24 into 2, which will be equal to 48, right? So option A is absolutely correct. But in the same question, if I ask you that how many arrangements are possible such that the consonants are in alphabetical order, right? How many arrangements are possible such that consonants are in alphabetical order? So what will be your answer? Consonants are in alphabetical order. Now tell me this. How many such words are possible where consonants are in alphabetical order? Let's see how many of you can get this correct. Siddhant, Anamika, Krishna, Rubal. No, not correct. Your answers are not correct. Think again. Paris, no, not correct. Siddhant, not correct. Gulab, Priyanshu, not correct. Consonants are in alphabetical order. See, 1, 2, 3, 4, 5. Now, we don't have any order for vowels, right? We don't have any order for vowels. Paris, yes, it's 20. That is correct. So, in how many ways I can put E? In how many ways I can put E in any of these 5 places? I can put E in any of these 5 places in 5 ways, right? Let's say I put E here. Then in how many ways I can put A? I can put A in 4 ways. Now let's say I put A here. Now in rest of the 3 places, as we need to arrange consonants in alphabetical order, that means R will come first, then T, and then X. So R will come here, T will come here, X will come here. Means number of ways of arranging these consonants will be 1. That is equal to 20. A total of 20 ways. Okay? A total of 20 ways. Is that clear? We can also solve it in other way. Okay? See, these 3 R, T, X. These 3 can be arranged in 3 factorial ways, right? For these 3 factorial ways, we need to select 1. Out of these, for every 6 ways, we need to select 1, right? For corresponding positions of vowels, there will be 6 ways we can put these. But out of these, we need to take only 1 way, which is RTX. So total, you can also find it, that total number of ways we can arrange these, all of these 5 letters in 5 factorial, but divide by 3 factorial, because instead of 3 factorial, they can be arranged in only 1 factorial. That is also 20. ठीक है? ओके, अंशिका बताओ क्या डाउट है, बोलो, किसी को डाउट है अभी भी यहाँ पे? जितने लोगों ने आंसर किए, रुबल, सिद्धांत, गुलाब, प्रियांशु, श्रीजा, बोलो, है क्या? नहीं नहीं नहीं, वॉवेल्स आर नॉट टुगेदर, आई एम गिविंग दिस क्वेश्चन, डिफरेंट क्वेश्चन. Biswajit got this correct, Paris got this correct, and then Biswajit. Ansika, see, 1, 2, 3, 4, 5. I asked that if consonants are in alphabetical order, in how many ways we can arrange all the letters. So, if consonants are in alphabetical order, R must come first, then T will come, and then X will come, right? So, whenever we have 3 places left, we can fill that 3 places in only one way, R, T and X. First place will be taken by R, then T, then X. So, now let us say how many ways vowels can be put in these 5 places. So, first letter E or A can be placed in any of the 5 ways, 5 places. Second letter can be placed in any of the 4 places. So, 5 into 4, 20, right? 5 into 4, 20. And these consonants can be arranged in only one way. See, if you put E here and A here, then what will happen? R, T and X will come here. Then again, if you put E here and A here, then R, T, X will come here. So, basically what we need to find is number of ways we can arrange E and A in these 5 positions. So, 5 into 4, 20. Okay, clear? Now, can you guys tell me the answer when instead of consonants, if I ask vowels are in alphabetical order? Tell me the answer. If instead of consonants, vowels are in alphabetical order. बताओ. देखो कैसे सभी लोगों के अब आंसर सही आ रहे हैं, है ना? एक बार अच्छे से समझने से मतलब है, एक बार अच्छे से समझ गए फिर मिस्टेक नहीं होगी, है ना? सो सेम थिंग, वी हैव 5 places, 1, 2, 3, 4, 5. So first now we need to arrange the consonants. So first consonant can be arranged in 5 ways, second in 3 ways, 4 ways and 3 ways. The vowels can be arranged in only one way. So 60 आ गया, हो गया सही, बस बढ़िया, बहुत अच्छे, बहुत ही अच्छे. Okay guys, let's try this question now. क्या रहा आंसर? ऑप्शन डी. How many integers greater than 5000 can be formed with the digits 7, 6, 5, 4 and 3 using each digit at most 1? So, it says greater than 5000, right? If we are talking about greater than 5000, it could be a 4-digit number or it could also be a 5-digit number. It's not given that it's a 4-digit number or 5-digit. So, we will have to consider both. Case 1, 4-digit number. How many 4-digit numbers are possible? 1, 2, 3, 4. So, out of 5 digits, 7, 6, 5, 4, 3, this place can be filled with 7, 6 or 5, right? And rest can be filled in anyways. So, this we can take as this place can be filled in 3 ways. Now, out of 5 numbers, you have taken 1. So, 4 is left, 4 into 3 into 1 into 2, right? Into 2. So, that will be equal to what? 36, 72, right? And if we consider case 2, that how many 5-digit numbers are possible? So, we have 5-digit and we need to find number of 5-digit numbers, right? There is no restriction here because any 5-digit number will be greater than 5000. So, it will straight be 5 factorial, which is equal to 120, and total it will be 120 plus 72, which is equal to 192. So, yes, we got some experts here not missing their chance. So, 192 is absolutely correct, guys. Okay. Now, let us move on to the next question, right? Okay, this one. Again, all of them are getting the same answer. Let's check it. How many ways can a committee of 5 made out of 6 men and 4 women containing at least 1 woman, right? Containing at least 1 woman. So, we can choose 1 woman, 4 men, 2 women, 3 men, 3 women, 2 men, 4 women, 1 man. Or what we can do, we can find the total number of ways that we can choose a committee of 5. So, total 6 plus 4 is equal to 10. So, out of 10 we can choose 5, which is 10C5, minus we can choose number of ways where all of them are men, right? Where all of them are men. So 6C5. This is what we need to do, right? यही करना है ना, और तो कुछ नहीं करना. Out of total 10 people, we need to select 5, and we need to subtract all the possibilities where all the 5 are men. So 10C5, what is 10C5? 10 into 9 into 8 into 7 into 6 divided by 5 factorial. 5 into 4 into 3 into 2 into 1 minus 6. So this value 5 factorial 120. 7 into 8 72 into 10 720. So this is 6 times. This will be equal to 252 minus 6, which is equal to 246. So our answer is option A. ठीक है? You can also solve it using this method, that 1 woman 4 men, 2 women 3 men, 3 women 2 men, 4 women 1 man. But this will be very time taking, है ना, बहुत ज़्यादा टाइम लगेगा इसे सॉल्व करने में. So instead we are going to use the just opposite, and we are going to solve this easily. Now this is a very interesting question. If you know the formula of NPR and NCR, then it's a very easy question. Otherwise it could be a little difficult question. So let's see. Thank you. It's an easy question. As I said, it's an easy question if you know that NPR means number of ways of arranging R things out of n things, which is n factorial upon n minus R factorial, and NCR is equal to n factorial upon n minus R factorial into R factorial. So this question can be written as n factorial upon n minus R factorial is equal to 720 into n factorial upon n minus R factorial into R factorial. So what will happen? N factorial cancel out, n minus R factorial is cancelled out. We are getting R factorial is equal to 720, and 720 is nothing but 6 factorial. R factorial is nothing but 6 factorial, or we can say R is equal to 6. So the answer is option C. ठीक है? NPR is equal to R factorial into NCR. Yes, that is true. This relation you can remember between these two is NPR is equal to NCR into R factorial. है ना? Remember, we are trying to practice as many questions as possible. So even if you have any doubts, okay, if I move to the next question, still you can ask your doubts, okay. So don't hesitate if any of you get any doubts. Now let's try this one. Now this says another type of question which could be tricky if asked properly. the number of words from the letters of the words Bharat in which B and H will never come together is. So once again, will never come together. What's the opposite of that? Will always come together, right? So what we can say? Total number of ways. In case of Bharat, 1, 2, 3, 4, 5, 6. We have 6 letters. So total number of words will be 6 factorial divided by 2 factorial, because we have 2 A's here, minus number of times, number of ways B and H will always be together, right? So what we can say, if I take B and H together, then we have A, R, T. So we have 5 entities. So B and H are always together. This will be 5 factorial upon 2 factorial into 2 factorial. 5 factorial upon 2 factorial. This 2 factorial is for 2 A's, right? And this 2 factorial is because this B and H can be arranged themselves in 2 factorial ways. So this will be equal to 360. 720 by 2, 360 minus 120, which is equal to 240. Okay. Now there is another way to solve this question, and that way is 1, 2, 3, 4, 5, 6. There are 6 letters, right? So alternate solution, method 2. Second method is very helpful if instead of 2 there are multiple letters. Let's say 3 letters can never be together. Okay, none of these could be together. So this method is really important. So focus here. See, what can we do is we have A, R, T. So let's place A, R, and T. Okay. Now we have 1 position, 2 position, 3 position, 4 position, 5 position. Now in any of these 5 position, if I put B and H, if any of these 5 position, if I put B and H, then they will not be together, right? So what we can say, that total number of ways will be. Now in how many ways I can put B here? So 1, 2, 3, 4, 5. In how many ways I can put H here? So 4 ways. Into, in how many ways? 1, 2, 3, 4. These 4 letters can be arranged in themselves. So 4 factorial upon 2 factorial, which is equal to 20 into 12, that is equal to 240. So this is a very important method. Okay, this method is good. As I said, this method is good, but this method is really, really good because it will help you solving other type of questions when more than 3 letters given that cannot be together. Okay. Rubal, first one is clear, method 1 is clear or not? Yes? In method 1, what we are doing, we are taking total number of arrangements, 6 factorial by 2 factorial, minus when B and H are together. So the cases that we are left is when B and H are not together. Now in this case, what I am doing is when B and H are not together, what does that mean? That between B and H, there will always be at least one consonant, right? Not consonant, any of the remaining 4 letters. Between B and H, there will always be at least one of the remaining letters. So remaining 4 letters. So I have arranged these 4 letters like this, A, R, T. And how many places are generated because of these? So I can put here or here or here or here or here. So in any of these 5 of 2 places I put B and H, they will not be together. Yes or no? Think about this. If any of these 5 places I put B and H, they will not be together, right? So it satisfied our condition, right? Hai ki nahi? So what we can do? These 4 letters can arranged in themselves in 4 factorial upon 2 factorial ways. Now in any of these 5 places, 1, 2, 3, 4 and 5, I can put B in 5 ways, H in 4 ways or vice versa. So 5 into 4 into this. अब आ गया समझ में, बताओ, ठीक है, क्लियर? है ना? चलो अब एक बात बताओ, जैसे कि एक लेटर, एक वर्ड ले लेते हैं, एजुकेशन। एजुकेशन, ओके, देर आर 9 letters, okay, number of ways, yeah, number of words such that you can say such that no two consonants are together. No two consonants are together is equal to what? अब बताओ, in how many ways we can rearrange the letters of this word education such that no two consonants are together? Can you answer this? Using this method you cannot solve this one, but if you use this you will be able to solve this quickly, easily, है ना? Try this one. No two consonants are together. Tell me the answer. How many letters are here? They are 9, right? Out of 9, consonants are 4. 4 consonants are there. Vowels are 5. सारे हैं A, E, I, O, U. A, E, I, O, U. Consonants are D, C, T, N, right? So we have D, C, T, N. Then we have A, I, O, U. क्या रहा आंसर बताओ? Even if you calculate the value and get, it will be very easy to calculate. Okay, it's not a big number. So what do we do? Consonants should not be together. That means between two consonants there must be at least one vowel. So let's put all the vowels: A, E, I, O, U. And how many new places will be there? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I can put these 4 consonants into these 6 places, right? So what will be the total number of ways? है ना? जहाँ तक मुझे numbers याद आ रहे हैं, अभी तक तो कोई correct नहीं है. Let's check here. So number of ways, first D can be placed in 6, then 5, then 4, then 3. Into these 5 vowels can be arranged in 5 factorial ways. So this will be equal to 120, 120, 14,400 into 3, 43200. That's your answer, right? अभी इस मेथड को हमने डिस्कस किया है ना. So these type of questions are not usually discussed because these are very difficult to make understand. Okay, but if you understand it, then it's really good. You can use it further, right? Sunidhi got this correct, that is good. And नॉयर का आंसर क्या है 24 इंटू 64 इज 15 360 नहीं वो सही नहीं है ना नहीं सही है वो भी सही है आई गेस नॉयर गॉट दिस करेक्ट प्रियांशु गॉट दिस करेक्ट एंड 4 फैक्टोरियल 5 फैक्टोरियल हाँ 43,200 इज करेक्ट दैट इज गुड ठीक है अब समझ गए हाउ डू वी सॉल्व दिस टाइप ऑफ क्वेश्चंस right? What if we arrange the vowels in 5 places? पेरिस नहीं वो अल्टरनेट के लिए होगा है ना इफ़ यू अरेंज द vowels in these 5 places तो आई गेस क्या हो जाएगा 4 फैक्टोरियल इंटू 5 फैक्टोरियल नहीं देखो दैट वुड बी when we are starting with vowels right तो इन दैट केस क्या हो जाएगा क्वेश्चन क्या हो जाएगा फिर स्टार्टिंग विद वॉवेल्स एंडिंग विद कॉन्सोनेंट राइट पेरिस बट दिस इज नॉट द केस इट्स नॉट नेसेसरी दैट ऑल ऑफ दीज वर्ड्स विल बी स्टार्टिंग विद वॉवेल्स है ना द अरेंजमेंट दैट यू हैव गिवन पेरिस ऑल द वर्ड्स विल स्टार्ट विद वॉवेल्स है ना ठीक है समझ गए 43,200 आ गया चलो पढ़िए Paris, I hope that is clear to you. Now let's try this one. Number of ways of selecting 4 fruits out of 4 apples, 5 mangoes, 6 oranges. Now remember in this question, these are 4 similar apples, 5 similar mangoes and 6 oranges because it says selecting exactly 4 fruits. So 4 similar apples, 5 similar mangoes and 6 similar oranges. Okay. Yes, they are not together in that too, but if the question is in how many ways vowels and consonants are in alternate place, then your answer is correct. 5 factorial into 4 factorial. ठीक है But if it says that no 2 consonants are together, that will be the answer. ठीक है Yes, identical. Akul, yes, identical. Rubal, you don't need to divide it by 4 factorial, 5 factorial, 6 factorial because of this similar. There is a different concept for it. है ना? There is a completely different concept for similar things. Let's say we have 10 similar books of iQuanta quantitative aptitude book. Okay, 10 books of iQuanta arithmetic book. Let's say iQuanta arithmetic book, 10 books. If I ask you in how many ways I can choose one book out of these 10 books, so answer is not 10, it's only one. If I want to choose 2 books out of 10 iQuanta arithmetic books, it won't be 10C2, it will be only one way because all the books are similar. So out of 4 apples, if you are choosing one apple, there will be only one way. If out of 4 similar apples, you are choosing 2 apples, there is only one way. It's not 4C2. So what we need to do? We need to consider the cases. See, apples, number of apples plus number of mangoes plus number of oranges should be equal to 4, right? And maximum 4 we can choose from any place, and any of these values could be 0. So whole number solution, number of whole number solution is equal to, now if you don't know about it, x1 plus x2 till xr is equal to n, then number of whole number solution is equal to n plus r minus 1 c r minus 1. This is what we are going to apply here. So there are three things where we need to choose these numbers. So it will be 4 plus 3 minus 1 c 3 minus 1, which will be equal to 6c2. 6 into 5 by 2, which is equal to 15. So this is the way, है ना? Number of non-negative solution, yes, x plus y plus z is equal to 4, that is 15. ठीक है, otherwise you will have to do it like this: number of apples, number of mangoes and number of oranges. You can choose this 0, this 4 0 0 or 3 1 0, or you can choose it as 2 2 0, है ना? यही होंगे ना, और कुछ होगा? 4 0 0 3 ways, 3 1 0 6 ways, 2 2 0, और क्या बच गया इसमें बताओ? 1 1 2 2 1 1. सो ये कितने हो गए? ये भी 3 ways. ये कितना हो जाएगा? ये भी 3 ways. सो टोटल 15, है ना? 4 0 0, 4 apples, 0 mangoes and 0 oranges, है ना? मैंगो से याद आया, सीजन ख़त्म होने वाला है, मैंगोज़ के दाम फिर से बढ़ने वाले हैं, है ना? तो जितने जल्दी हो इस सीज़न के मैंगोज़ ख़त्म कर दो, है ना? फिर 1 साल के बाद ही, 1 साल नहीं तो 8-9 महीने के बाद ही, मैं भी यही प्लान कर रहा हूँ कुछ दिनों से. ओके गाइस, इज दैट क्लियर नाउ? This is what we are doing in shortcut here, all right? Okay, let's try this one. Guys, if you like our videos, then don't forget to click the like button, है ना? Don't like these videos in your mind only. Click the like button, share it with your friends who can be profitable with this. It's totally free, going on every day of the week except Sunday, right? तो उसमें कंजूसी नहीं करेंगे. Find the number of ways in which 8064 can be resolved as a product of two factors. So you can use the direct shortcut here, है ना? That number of ways n can be written as product of two factors is equal to number of factors of n divided by 2, right? Number of factors of n divided by 2. So how do we find the number of factors? 8064 can be written as 2 to the power 7 into 3 square into 7 to the power 1. So what we can say, number of factors will be equal to 7 plus 1 into 2 plus 1 into 1 plus 1, which is equal to 8 into 3 into 2, and that is equal to 48. What we can say, number of ways will be equal to 48 by 2, that is equal to 24. है ना? Siddhant, what's the number you got? Mistype hai. Akul got this correct. Paras, Guru, Nivedita, Bhavana, it's Bhavana I guess, Rubal, Priyanshu, Anamika, Nivedita. Good. All of these students got this correct. Answer is option D, which is 24. Any doubts here? If you have any doubts, then let me know. For any number n, this is true, that number of ways n can be written as product of two factors will be equal to number of factors of n upon 2. Now, can anyone tell me, find the number of ways in which 8064 can be resolved as product of two co-prime factors? How many of you can answer this question? Let's see. If I change this question a little bit, that can be resolved as product of two co-prime factors, then what will be the answer? क्या होगा इसका आंसर बताओ? Changing the question a little bit here. Four co-prime pairs, right? Four co-prime pairs, that is correct, है ना? That is correct. Is equal to 2 to the power k minus 1, where k is equal to number of unique prime factors. ठीक है? So k कितना हो गया यहाँ पे? K will be equal to 3. 2, 3 and 7. So क्या हो जाएगा इसका आंसर? इसका आंसर हो जाएगा 2 to the power 3 minus 1, which is equal to 2 square, and that is equal to 4. ठीक है? All right. चलो. Let's move to the next question. This one. Ritik is asking how you got 8064 value so quick. It was not quick, है ना? ये numbers I had factorized earlier. That's why I remember it. है ना? इतनी जल्दी कैसे करेंगे factorize? But yes, I can find that 8064 is divisible by 64. Okay. Why? Because 8000 is divisible by 64, and 64 is also divisible by 64. If I divide this by 64, I am getting 1, then 2, and then 6. Then again dividing this by 64, 2, I will get 63. Okay, Ritik? Akul, what will be the answer if it is none of these? Nine आएगा. Yes, that is correct. how many numbers can be formed with the digits 1, 6, 7, 8, 6, 1, so that the odd digits always occupy the odd places. So 1, 2, 3, 4, 5, 6. This is first place. This is second place, third place, fourth place, fifth place, sixth place. Always we count the place from left to right. Okay, first place, second place. That's why this one is known as last place. Okay, now we need to put 1, 1, 7 here, and then we can put 6, 1, 3, 5, right? So 7 will be here. 1, 1, and then 7. 6, 6, and then 8. So total number of ways 1, 1, 7 can be arranged in themselves in 3 factorial by 2 factorial. Then 6, 6, and 8 can be arranged in themselves in 3 factorial by 2 factorial. That is equal to 9, and answer is option D, none of these. ठीक है, चल let's move on to the next question, this one. अकुल पर क्वेश्चन टाइम ऐसा कुछ डिफाइन नहीं है, बट देर आर आई गेस 36 क्वेश्चंस इन 52 मिनट्स, सो दैट्स अप टू यू, है ना, दैट in NMAT exam is just based on the format of GMAT, okay, where if you solve a question incorrectly, next question will be of similar level or maybe level lower than that, and if you solve it correctly, next question will be of similar level or higher than that. So there is no particular time per question that you can count. Overall 52 minutes, 36 question. 16 by 36 is 4 by 9. 4 by 9 is 80 by 3, 26. So 1 minute 26 seconds, you can say, if we are talking about average, right? In this question it says, if a secretary and a joint secretary are to be selected from a committee of 11 members, then in how many ways can they be selected, right? So what will happen? Out of 11 we need to choose 2 people first. Out of 11 we need to choose 2 people first, and then those 2 people, one of them can be secretary, other can be joint secretary. So those 2 people can be arranged in 2 factorial ways. This will be equal to, basically this is nothing but 11 P2 as well. Out of 11 people you need to arrange 2 people, right, which is equal to 11 factorial upon 9 factorial. That is equal to 11 into 10, which is 110. पेरिस क्वेश्चंस आई डोंट थिंक किसी भी ऑर्डर में अटेम्प्ट किए जा सकते हैं, ऐसा तो नहीं है. सेक्शन, yes, you can decide about the section, that which section you can attempt first, which section you can attempt second, है ना. Not in case of question. You don't get to go back. Whenever you have a computer adaptive test, you cannot go back, okay, and NMAT is just like GMAT, so उसमें भी नहीं जा सकते पीछे, ठीक है. Okay, chalo, let's try another question based on the similar concept that we did in the last question. during NMAT exam, make sure that initially few questions you don't get wrong, है ना, so that the level of the questions that you are getting is always of good level, and that's why scaling, when scaling is done, your marks are relatively good. So try to make first few questions correct, but that does not mean that you spend lots of time in first few questions, you are not able to do most of the questions, है ना, ऐसा भी नहीं करना है. बट येस, क्वेश्चन उस लेवल के नहीं आते कि बहुत ज़्यादा टाइम वेस्ट किया जाए, या तो जल्दीबाजी में गलती कर सकते हैं या फिर गलती से गलत ऑप्शन मार्क कर सकते हैं ना, ये दो चीज़ें ज़्यादातर होने के चांसेस होते हैं, तो उसे अवॉइड करेंगे. इफ़ योर प्रिपरेशन इज़ गुड, you should not be having hard time getting good score in NMAT. In this question, on a railway route there are 20 stations. What is the number of different tickets required in order that it may be possible to travel from every station to every other station? One station to every other station. So out of 20 station, I want to travel 19 other station, right? One station to 19 stations ticket can be printed. So what will be the total number of ways? 20 into 19, which will be equal to 380, है ना. जैसे कि अगर 4 स्टेशन है, A, B, C and D, so I will have to print a ticket AB, then AC, then AD, then I will have to print a ticket BC, BD, CD. Then BA will also be a ticket which is different from AB. AB is you can go from A to B. BA is from B to A. So all of these will be different, है ना. So it will be 4C2 into 2 or 4P2, which is 380 here. Okay. Now this is a very interesting question. Let's see how many of you can get this correct. Yes, sum will always will be non-zero in this case, है ना. The number of different sums of money C can form from them is, it will be non-zero, correct. One, 2, 5, 10. 15, correct. See, if I am taking only one notes out of 4, there will be 4 sums. If I am taking 2 notes, then 4C2, and none of these two are equal. 1 plus 2, 2 plus 5, 5 plus 10, 10 plus 1, we also be sure of that. Now denominations are such that no 2 are equal to any other, no pair is equal to any other pair, but if situations are like that, you will have to consider that. Then out of 4 I can select any 3, then out of 4 I can select any 4, which will be equal to, this will be equal to, now this one concept that you should know, NC0 plus NC1 plus NC2 till NCn is equal to 2 to the power n. So this value will be equal to 2 to the power 4 minus 4C0. This is not here. 4C0 is 1, which is equal to 50. ठीक है, 2 to the power 4 minus 1. Correct. If you calculate all the values, it will take lots of time. 1, 2, 5, 10. एक एक नोट अगर लिए तो दो नोट लिए तो 1, 2, then 1, 5, then 1, 10, then 2, 5, then 2, 10, 5, 10. You can take all 3 as well, all 4 as well. Okay, now let's try this one. How many times does the digit 3 appear while writing the integers from 1 to 1000? Anamika, PNC for cat, sure. Very soon we are going to have sessions, marathons on different topics, and we are going to take sessions on PNC, okay? ये वाला अच्छा है चलो बढ़िया है, ठीक है. इसके आंसर्स याद हो जाते हैं ना, अगर ढंग से पढ़ाई करो तो ऐसे क्वेश्चंस के आंसर याद हो जाते हैं आपको. अदरवाइज काफ़ी टाइम लगता है सॉल्व करने में. ऑप्शन सी 300 इज एब्सोल्युटली करेक्ट. देखो एक शॉर्टकट में बताऊंगा. वी नीड टू काउंट फ्रॉम 1 to 1000, राइट. सो 1000 की जगह अगर 999 भी रखें, इट वोंट चेंज अ थिंग. सो स्टार्टिंग विद 000, राइट इट लाइक दिस, 001, 002, ऐसे 999 तक अगर लिखें तो टोटल कितने डिजिट्स हो गए? नंबर हो गए 1000 into 3. There will be 3000 digits. There will be a 3000, total of 3000 digits. And how many distinct digits do we have? We have 0 to 9, 10 digits. So each digit will come, right? So 3000 upon 10. Each digit will come 300 times. Each digit will come 300 times. है ना? कितनी मज़ेदार बात है. अब ये देखना है कि इसे प्रॉपरली कैसे सॉल्व करें, है ना. यस, ये बहुत ही कॉमन क्वेश्चन है. फ्रॉम 1 to 99, फ्रॉम 1 to 99, any digit except 0 is used 20 times. 1 is used 20 times, 2 is used 20 times, 3 is used 20 times, and so on. Okay. Then from 101 or 100, you can say 101, फर्क नहीं पड़ता, 100 to 199, again it will be 20 times. From 200 to 299, it will be 20 times. From 300 to 399, it will be, now this 3 is common in every number, so it will be 100 plus 20, which is equal to 120 times. ठीक है. Then in rest of them it will be, so total 20 into 9 plus 120, which will be equal to 300 times. ठीक है. So 3 will be used 300 times, 1 will be used 300 times, 5 will be used 300 times, all of these. Okay, everyone, I hope this is clear. Now the most important part is this one, from 1 to 99, how many times digit 3 is used? 20 times. In how many number digit 3 is used? 19 times. 19 numbers, because in 33 it will be used twice. Okay? चलो ये क्वेश्चन भी कर ही लेते हैं, है ना. हाउ मेनी वेज कैन 12 गर्ल्स बी अरेंज्ड इन अ रोज इफ 2 पर्टिकुलर गर्ल्स मस्ट ऑक्यूपाई द एंड प्लेसेस. बहुत स्ट्रेट फॉरवर्ड आंसर है इसका. इन हाउ मेनी वेज कैन 12 गर्ल्स बी अरेंज्ड इन अ रो इफ 2 पर्टिकुलर गर्ल्स मस्ट ऑक्यूपाई end places. So forget about those 2 girls, right? We are left with 10 girls. Those 10 girls can be arranged in 10 factorial ways, and the remaining 2 girls can be arranged in end places in 2 factorial, left and right end, which is option C. That's your answer. ठीक है. Now one fun fact about factorial is basically m plus, not m plus n. Let's say we have p factorial is equal to q factorial into r factorial. Do you know the value of p, q and r? Do you know this? How many of you know this? P factorial is equal to q factorial into r factorial. All of these are distinct, okay? P is not equal to q, is not equal to r, okay? And yes, just a fun fact, not related to this question, only a fun fact. Six, 5, 3. P is equal to 6, Q is equal to 5, R is equal to 3. Okay. 6 factorial is equal to 5 factorial into 3 factorial. Any other combination that you know? कोई और combination है? सोचो, बहुत ज़्यादा बड़ी वैल्यूज़ भी नहीं है, है ना. अपार्ट फ्रॉम दिस देयर इज ऑल्सो वन मोर कॉम्बिनेशन. है क्या? बाकी कॉम्बिनेशन यूनिक नहीं बन रहे है। देखो 10 फैक्टोरियल इज इक्वल टू 7 फैक्टोरियल इंटू 6 फैक्टोरियल। बताओ ट्रू है या नहीं है? अकुल देखो 8 इंटू 9 इंटू 10 इज 720 विच इज़ नथिंग बट 6 फैक्टोरियल, है ना? हाँ ठीक है, कोई बात नहीं, ये सॉल्व नहीं करना था। आई सेड इट्स अ फन फैक्ट, राइट? तो अगर जानते हो अच्छी बात है, नहीं जानते हो तो कोई बुरी बात नहीं है, उसी के लिए ये डिस्कस किया मैंने, है ना? यस 5040 इज इक्वल इंटू 720 इज 10 फैक्टोरियल। चलो बढ़िया। So that's the end of the session, guys. I hope you got a good revision, right? And got to learn something as well. And I hope all of you will be here when we start the session tomorrow at 3 p.m. Okay? Again, don't forget to subscribe the channel, like the video, and put your feedback in the comments. Thank you.